You know the quadratic formula. It's a beast, right? Super powerful, always gets the job done, but wow, it can be a lot of steps. But what if I told you there's a secret? A kind of crystal ball hidden right inside that formula, a little shortcut that lets you predict an equation's future without doing all the hard work. Let's find it.
So have you ever been in this spot? You're staring at a quadratic equation, and the test isn't asking, what's the answer? It's asking, how many answers are there? Sometimes all you need to know is if you're looking for 2 solutions, or just one, or maybe even none. And you need that answer, like now, without having to wrestle with the entire formula.
Well, you are in luck, because of course, there's a really slick shortcut built for exactly this. It lets you figure out what kind of solutions you're dealing with in one quick, easy calculation.
Now, to find this shortcut, we don't have to learn some brand new complicated thing. Nope, we just need to look a little closer at the formula we already know. We're about to zoom in on the heart of the quadratic formula and find its secret. And there it is. It's called the discriminant. Yeah, the name sounds a little fancy, I know, but all it is that little piece of the puzzle hiding under the square root sign, b squared minus 4ac. This one little value has the power to discriminate, to tell the difference between the kinds of answers you're going to get.
So the big question is, how? How can this one little piece of a much bigger formula tell us everything we need to know? It kind of feels too simple, right? But the logic here is actually super solid, and it all has to do with where it's located in the formula.
Okay, so check this out. It all boils down to where the discriminant, let's just call it d, is sitting. See how it's right next to that plus or minus symbol? That symbol is everything. It's basically a fork in the road, the spot where one equation can split off into 2 different paths. And the value of d determines exactly what happens at that fork.
Just think it through. If d is a positive number, like 25, you're going to take its square root, which is 5. So you'll be adding 5, and you'll be subtracting 5. Those are 2 totally different operations that give you 2 totally different results. Boom, 2 real solutions. But what if d is 0? The square root of 0 is just 0. Adding 0 and subtracting 0, it's the exact same thing. The path doesn't split. You only get one answer.
And that brings us to the last possibility. What happens if d is a negative number? Well, you can't take the square root of a negative and get a real number, right? That's when we jump into the world of imaginary numbers, and we get something like 3i. But remember that plus or minus sign, it's still there. So you're going to have a plus 3i and a minus 3i, giving you 2 complex solutions. All right, so that's the why behind it. Now, let's just boil this all down to 3 simple rules. This is the stuff you really want to lock in. The discriminant can make 3 and only 3 predictions about your equation. In this table right here, this is your cheat sheet. It's this simple. If the discriminant is positive, the graph of your parabola is going to cross the x-axis in 2 different spots. If it's 0, the very bottom of the parabola just kisses the x-axis at one single point. And if it's negative, the parabola is just floating, either completely above or completely below the axis, never touching it at all.
Okay, theory is cool and all, but let's see just how fast and powerful this tool really is with some actual equations. We're going to put the discriminant to the test and see what it tells us. Let's do this. All right, first up, we have x squared plus 4x plus 3 equals 0. So our a is 1, b is 4, and c is 3. Let's just plug those numbers right into our discriminant formula. So we get d equals 4 squared, minus 4 times 1 times 3. That works out to 16 minus 12, which is 4. The number 4 is positive. And that's it. That's all we need. We can instantly predict that this equation has 2 distinct real solutions. We didn't solve for x at all. Pretty cool, right?
Okay, next one. Let's try x squared plus 6x plus 9 equals 0. For this one, a is 1, b is 6, and c is 9.
Let's plug them in. D is 6 squared minus 4 times 1 times 9. Well, that's 36 minus 36, which is 0. And the second we see 0, we're done. We know there is exactly one real solution. Oh, and here's a little pro tip. If you ever get a discriminant of 0, it means your original equation was a perfect square trinomial. All right, one last example to cover our final case. What about x squared plus x plus 1 equals 0? This one's easy. Our a, b, and c are all just 1. Okay, let's run the numbers. D is 1 squared minus 4 times 1 times 1. So that's just 1 minus 4, which gives us negative 3. And that negative sign tells us everything. There are no real solutions here. Instead, we have 2 complex solutions. And look at that. We just predicted the fate of 3 different equations in, a few seconds each? That's the power of this thing. Now, using the discriminant is super straightforward, but there are a couple of really common mistakes that can trip people up. Let's just go over them real quick so you can make sure you get the right prediction every single time.
Okay, this is the #1 mistake, so listen up. The discriminant is the value inside the square root, not the square root itself. Remember that first example where we got d equals 4? We don't care about the square root, which is 2. We only care that the number 4 itself is positive. That's it. Positive, negative, or 0. That's all you need to know.
And the other classic mistake? Simple sign errors. You have to be so careful with those negative numbers, especially if your c term is negative. That minus sign in the -4ac part means a negative c will flip the whole term positive. If you miss that, you could easily think a positive discriminant is negative, and you'll get the completely wrong answer.
So you might be thinking, okay, this is a cool little math trick for my next test. But the discriminant is actually way more than that. It shows up in the real world, helping us make predictions about all kinds of things. I mean, check this out. Imagine you're a physicist with an equation that describes a rocket's flight path. Just by calculating the discriminant, you can figure out its destiny. If d is positive or 0, that rocket's path is going to intersect a height of 0, meaning it's coming back down to Earth. But if d is negative, its path will never cross a height of 0. Maybe it achieved a stable orbit, or maybe something went wrong. The point is, the math tells the story before it even happens. So, there you have it. We found a crystal ball hiding in plain sight, right inside the quadratic formula. It really makes you wonder, doesn't it? The math that we learn isn't just a random set of rules. It's a whole toolbox filled with these elegant shortcuts and amazing connections. So the next time you're looking at some formula, ask yourself, what else is hiding in there?